Welcome to another episode of Burning Questions. In this episode, we're going to be covering more of your burning questions. Many of them are covered in our Knowledge Hub on the website, but specifically today we're going to talk about how you should firestop fire-rated ducts and dampers. So ducts and dampers are tested to a different standard to other surface penetration seals. So fundamentally, your first question really should be to the fire-rated duct or damper manufacturer as to what they recommend you should do to firestop their duct or their damper. Now, it may well be that some manufacturers will say you can use a certain batt of a certain density and an intumescent acrylic sealant, which has been tested to BSEN 1366 Part 4, for instance, and in which case the QuelStop Fire Batt and the QuelStop sealant may meet their specification. In which case you could use our products in accordance with their test evidence and their recommendations. Now, in addition to that, QuelFire have carried out some specific testing. So we have carried out some specific testing with the QuelStop System, the QuelStop Batt, the QuelStop sealant on a number of different dampers. So we have an example of one of our details there with the batt installed within a framed and lined aperture within a fire-rated flexible, which would also cover a rigid wall. And the detail here is also using the QuelFire QF2 fire protection compound, again on some specific dampers. As I say, starting point, ask the damp or duct manufacturer. Alternatively, we have some unique details as well. Any further questions? Check out the Knowledge Hub or give us a call. Another great question we get asked is about how to deal with shower gullies. So many people may say, well, they're a plastic pipe. Yes, they're plastic. There is a fundamental difference. With a plastic pipe, it's expected that the pipe would carry on past the floor penetration, the point of penetration. So under the requirements of BSEN 1366, we have to test plastic pipes with at least 500 millimeters of pipe each side of the seal. Now, with a shower gully scenario, you don't have that pipe protruding on the non-fire side, the top side of the slab. So for these sorts of scenarios, you really need a bespoke tested solution. So we have at QuelFire, we have tested in conjunction with the McAlpine shower gully, which is the one you see on the screen here. So it's effectively a plastic shower gully reducing down to a smaller diameter plastic pipe coming out of the bottom of the slab. So we've tested solutions using the QuelStop HPE graphite sealant. So the example you see on the screen there is with the HPE sealant applied directly within the depth of the concrete floor slab. We've also tested a version using HPE sealant, as I've just described, within the slab, and that then has an additional layer of HPE within the fire batt, which is also fitted to the underside of the slab. So you've got an extra depth of sealant. Now, what you may or may not be able to see there is that the pipe bends and is tucked very neatly and tightly to the underside of the soffit, which is typical. So we have tested the HPE effectively as a horseshoe around that plastic pipe as it turns. So as I say, could you use data for standard plastic pipes? Well, no, because you haven't got the protrusion, but we have got some bespoke tested solutions there for the McAlpine shower gully. So once again, any further questions on this, give us a shout. A common method of construction when it comes to steel frame buildings can be the use of a cellular steel beam. So we often get asked, how do you firestop a cellular beam? Well, really, we're looking at two separate things. QuelFire are coming at it from a service penetration thing, which is products and solutions tested to BSEN 1366 Part 3, and the steel beam itself needs to be separately protected for structural integrity. So when we start putting services through a cellular steel beam and then put the cellular steel beam on a compartment line and we need to fire stop the hole through the cellular steel beam, we're trying to combine two standards. So the bottom line is you shouldn't be running services through cellular steel beams on a compartment line because there won't be a specifically tested solution for it. Now, we may have data that could be considered by a qualified person for an engineered judgment or a technical assessment, but that would need to be looked at on a project by project basis. So my suggestion to you is that wherever possible, you design out any service penetrations through cellular steel beams on compartment lines. So the question comes up sometimes as to why standard installation details for copper pipes can be used on steel pipes, and also why details for steel pipes cannot be used on copper pipes. So I'm going to quote a little section here from BSEN 1366 part 3, and it's Annex E, section E.4.2.3. If you want the detail, contact us if you want references. What it says is that effectively, if you test worst case scenario, it covers better case scenarios. So what it says is that results of tests conducted in standard configurations on a particular pipe material cover pipe materials with a thermal conductivity lower than that tested, subject to the material having a melting point at least equal to that of the material tested or greater than the nominal furnace temperature at the required classification period. So effectively, copper is a better conductor of heat and has a melting point compared to steel, which allows you to test copper and automatically cover things like steel, stainless steel, cast iron, because, as I say, it's a better conductor. So it's a worst case scenario when it comes to fire testing. So on the flip side of that, if you test a steel pipe, it will only cover you for steel pipes because a copper pipe is a better conductor of heat effectively. So as I say, bit of a complex one, but really important one. Copper pipe details cover you for steel, stainless steel, cast iron, where it meets all those requirements, i.e. melting point and thermal conductivity, but steel pipe data does not cover you for copper pipes. So I hope that clarifies. The question in relation to steel and copper pipes is in relation to the insulations that are used. So the question is often, well, what insulation can we use? What insulation is covered? So as you can see on this demo board here, we've got three very specific types of insulation. So here we have a mineral wool, which is effectively a non-combustible material with a foil outer to it. Here we have a highly combustible Kingspan Cooltherm phenolic type of insulation, which again has this foil on it, but it is in reality a combustible insulation. And again, we have another highly combustible insulation, in this case an Armaflex or an elastomeric insulation. The point is there are a number of different insulations. Those insulations behave differently in a fire. They of course need to be suitably fire stopped. With mineral wool type products, maybe not so much need for a closure seal, but certainly with the combustible types of insulation, you would be needing a seal such as the QuelCoil Inchi Wrap. So although the pipe itself is non-combustible and doesn't require a closure device, the insulation does or may well do. So there are lots of tested details for lots of different diameter pipes, different insulations, and of course different orientations through walls, through floors, and of course different types of walls, single batt, double batt, pattress batt details again. So really important that you look for the specific tested detail for the specific pipe size and type and insulation type and thickness too. A really important question, and a question which actually really sets QuelFire apart, is how much overlap is required when pattress fitting QuelStop Fire Batt. So first of all, let's just talk about what pattress fitting is. Pattress fitting is when we fit the batt to the outside of the wall rather than inside a letterbox. So there is obviously a critical amount of overlap of batt onto the integral fire rated plasterboard wall. Many installers are used to having to install 100 millimeters of overlap, and indeed that's good practice, but unfortunately in today's challenging environment we don't always have that luxury. So that's one of the reasons why QuelFire have tested just a 50 millimeter overlap on the batt. So that's 50 millimeters of batt onto the wall. Now furthermore, we've tested that detail with just 30 millimeters overlap on the underside. So this is particularly useful where you've got perhaps ceiling voids, where you've got very limited space to actually fit the batt. So as I say, QuelFire's details, 50 mil overlap on the sides, along the top, and just 30 millimeters of overlap on the bottom. The fixings are to be installed in the center of that overlap, and there's obviously specific fixings for specific scenarios. Once again, check those standard details. And it's worth remembering that you are trying to install a fixing halfway into an overlap, so a 50 mil overlap, that's just 25 millimeters from the edge. So whilst it can be achieved, and indeed we've achieved it, we've tested it, all our standard details cover it. If you can get 100 millimeters overlap, then why wouldn't you? Certainly, good practice to aim for 100 millimeters, but certainly nice to know that we do have that test evidence to support it, and that could really make the difference in being able to install a tested detail or not. So for any further questions on that, give us a shout. We'll be glad to help and explain further. Question sometimes comes up around whether you can mix and match different products from different manufacturers. The short answer is no, you can't. In reality, products will have been tested in conjunction with each other as a system. So if you were to substitute one of those products and introduce another product from another manufacturer, there would be no guarantee, unless for some strange reason there was some test evidence that those products were going to work in conjunction with each other. So short answer is no, always install to the tested detail using products from a single source manufacturer. The last and final question we're covering in this episode is around the working life of the QuelStop system. What is the working life of the QuelStop system? It's a tricky question, but it's a good question. It is one of those questions that is answered on our Knowledge Hub, so please check out the details on there. Effectively what it states there is that whilst manufacturers may give a projected life expectancy, and I'm quoting here from the best practice guide, there is no standard to measure these claims against. Now, as part of the ETA and CE marking process we go through, then we do carry out durability tests which state 10 years. Now, clearly a building would be expected to last longer than 10 years. And indeed, you might be expecting to have a projected life expectancy of the products longer than 10 years. That's understandable. But because there is no clear standard, we can't necessarily state what that life expectancy is beyond 10 years. However, QuelFire have been in business for over 45 years, which says something, and we don't know of any issues, provided the products have been installed correctly, and of course the products were stored correctly prior to installation. So it would be normal to expect the products to be able to last the lifetime of a building, and certainly more than the 10 years. But it is a tricky question, but check out the piece that's on our website within the Knowledge Hub, because there's lots of useful reference documents there you can refer back to. So thanks for listening to this episode of Burning Questions. You can check out the other episodes and other frequently asked questions in our Knowledge Hub on the website, or of course, don't hesitate to get in touch. We'll be glad to help. Thank you.